Next topic is speech recognition. So speech recognition क्या होता है? Speech recognition is the task of identifying a sequence of words spoken by a speaker given the acoustic or audio signal. So this is a simple or the basic definition in which you can define or by which you can define the speech recognition. So it has become one of the mainstream application of AI, as you know, and million of people, they're interacting with the speech recognition systems every day. Why? Because of many reasons, and some of them I have listed here. So these are like to navigate the voicemail systems. Second is search the web from the mobile phones and voice text conversion, and there are many more applications like this, and because of which the speech recognition systems, they are in demand. Speech is an attractive option when hands-free operation is necessary. If we want to operate any machine hands-free, then speech is the very attractive option as when operating the machinery. Okay. Next thing is that speech recognition is a software program accept the sound as input and convert it into the written language, both the computers and humans can understand. And it uses the 4 steps to convert the speech to text. So as you know, by the definition of speech recognition, that it's a task of identifying the sequence of the words spoken by the text speaker. So from the speaker, the words which are spoken by the speaker, we need to identify the sequence of the words. So here we are using 4 steps to do so, to convert the speech to the text. First thing is that you have to analyze the audio and then break it into the part. Third is digitize it into a computer readable format, as you have to convert the speech to text. And lastly, you have to use an algorithm to match it to the most suitable text representation. So these are the 4 steps which are followed in SR, in speech recognition. That's a computer program which accepts the sound as input and convert it into the written language. So the basic or the main aim of the speech recognition system is to convert the sound into the written language, or you can say the text. There are certain issues in speech recognition. So there are we have studied that what is the speech recognition, what are the examples of speech recognition, what is the procedure, what are the steps involved in it, and now we're gonna see that what are the issues in speech recognition. So speech recognition is difficult. Why? Because of many reasons. First is that because the sound made by the speaker can be ambiguous and sometimes can be noisy. As a well-known example, the phrase recognize speech sounds almost the same as rack a nice speech. So recognize speech, and the other sentence is rack a nice speech. So while spoken quickly, the sounds almost the same. So it is very difficult to convert such type of the sentences into the text, because in sound they are almost similar, but they are totally different sentences. So this is the major issue in speech recognition. Then segmentation. Written words, they have spaces between them, but in past speeches there are no pauses. For example, in recognize, that would distinguish it as a multi-word phrase as opposed to a single word, recognize. So the segmentation problem is there. Then co-articulation. Co-articulation means that when speaking quickly, the S sound at the end of nice merges with the B sound of the beginning of beach. So the end sound of a particular word, it merges with the starting, or you can say the beginning sound of the other. It is referred as co-articulation, and L is something that is close to a sub. So here I have mentioned an example. Co-articulation means that when the end sound of a particular word, it merges with the starting or the beginning sound of the another word. That is the co-articulation. And when speaking quickly, the S sound at the end of the line. This is just an example. Okay. Now we have homophones. So homophones, the words like to, T double O, this is also to, and TWO, this is also 2. So we have these three too, and they have different meanings. But in speaking, when I'm speaking these words or when I'm saying these words, they sound same. So that sound the same, but they are different in meaning. So these are the homophone, and this is the issue in speech recognition. That if a person is saying this too, then how we can convert it into TOO, because it can be TO, TWO. How do we know that it's TOO, not TW or TO? So this is a problem of homophones. Then there are three models: noisy model, noisy channel model, acoustic models, and language models. So first we'll see these models one by one. First is noisy channel model. Noisy channel model is that an original voice message, when an original voice message is transmitted over a noisy channel, let's say it's a telephone line, such as a corrupted message are received at the other end. A ceiling fan is about 5,000 times more likely as the word sequence than ceiling fan. So they're very similar to one another, only there's a difference in spelling, you can say. And it is possible to recover the original message with small error if we encode the original message in the written in enough way. So the applications are speech recognition, MT, and spelling correction, and the other tasks. So this model is that when an original voice matches, when you are just transferring a message over the noisy channel such that the corrupted message is received at the other end. So this is the noisy channel model. Second is the acoustic model. Acoustic is that let's say sound waves. Sound waves, they are the periodic changes in pressure that propagate through the air. Since we only want to know that what words were spoken, not exactly what they sounded like, so we need to distinguish between the speech sounds. Like linguistics, they have identified about 100 speech sounds or the phones that can be composed to form all the words in all the known human language. A phone is correspond to a single vowel and consonant, but there are many, or you can say some complications. The combination of letters such as th, the, and ng, they produce the single phone, or you can say sound. Now, identifying the variation in sound is very important. It can be loud, it can be soft, fast, low, male, female voice, etc. So identifying the variation in the sound is very indispensable. And this is the acoustic model says that the speech systems, they translates the acoustic signals into the sequence of frames, like the time slice of the signal, as you can see in these diagrams or in the figure. So in this diagram, each frame is described by discrete values of the three acoustic features, and a real system would have the dozen of features. And the overlapping of the frame, as you can see here, there can be the overlapping. So, and the overlapping frames, they are used to make sure that we wouldn't miss a signal, because it happens to fall on frame boundary. Okay, so overlapping frames, they are used to make it sure that we don't miss a signal. Last is the language model. Language model can be an n-gram model. We have studied that what is an n-gram model, and language model is quite similar to it, or it can be this model of the text learned from a corpus of written sentences. The spoken language has different characteristics than the written language, and for task specific speech recognition, the corpus should be task specific. To build your airline reservation system. Okay, so this is just an example that if someone wants to build the airline reservation system, then the speech recognition, it also helps to have the task specific vocabulary that would be same to that in those tasks. Suppose there is an airline reservation system, so if the vocabulary is related to this system only, then it can be applicable to any airway, any airline reservation, a list of all the airports in the city served and all the flight numbers. So, if the corpus should is the task specific, then it should be helpful, or you can say applicable, while we are gonna uh, deal with such systems, such task specific systems. Building a speech recognizer. The quality of a speech recognition system depends on the quality of all of its component, and these are the language model, the word pronunciation model, and the phone models, etc. The single processing algorithms used to extract the special features from the acoustic signal, and the large pronunciation dictionaries that are available for English and the other language, and although their accuracy varies greatly. Okay, so here the quality depends on the quality of all the components, and these are the components. And the signal processing algorithms, they try to feature, and we use these algorithms to extract the features from the acoustic signals. Now, is it easy to build a system from the corpus? So building a model from the corpus is more difficult than building an n-gram model of text, because we have to build a HMM, hidden Markov model. It is very much important. So the phone sequence for each word and the phone state for each time frame are hidden variables. And recent systems, they use expectation maximization algorithm to automatically supply the missing data. So the systems with highest accuracy work by training a different model for each speaker, and thereby capturing the differences in language as well as male, female, or the other variations. Now, this training can require the several hours of interaction with the speaker. Now, what is the accuracy of a system? Accuracy of a system depends on the number of factors. For example, I have listed these factors. First is the quality of the signal, matters a lot. And vocabulary size also matters. Third is task also matters. And the last is the accuracy of the system. It also depends on the quality of signals to the extent possible. So a high dimensional directional microphone with a stationary mount in a plated room will give high accuracy in comparison to a cheap microphone. Because cheap microphone transmitting a signal over phone lines from the car in traffic with the radio playing produces poor quality. So it is very much understandable, or it is very much as you can say, by just referring to the words like cheap microphone and high quality directional microphone, one can easily say that high quality directional microphone will give high accuracy in comparison to the cheap microphone. And now we have this vocabulary size and these tasks. These are the factors on which the accuracy of the system depends. And while we talk about the vocabulary size, then when recognizing the digit strengths with a vocabulary of 11 words, 1 to 9 plus O plus OH and the 0. So the word error rate will be below 0.5%, whereas it rises to about 10% on news stories with a 20,000 words vocabulary, and 20% on the corpus with 64,000 words vocabulary. So this is the data, you can say. And you can say that the accuracy highly depends on the vocabulary size. So while recognizing the digit strings with the vocabulary of 11 words, so the error rate is below 0.5%. And when it rises to 20,000 per words vocabulary, then the error it rises above 10%. So that is quite high. And with the 64,000 word vocabulary, it is 20%. So vocabulary size does matters. And last is the task. So when the system is trying to accomplish a specific task like booking a flight or give direction to a restaurant. So the task can often be accomplished perfectly. Okay. Now this is it. This is the machine translation, the statistical machine translations, and natural language processing. These subtopics, they comes under natural language processing. Now the next thing is robot, and in robot we'll study that what is hardware, what is perception, what is planning, and what is movable parts, you can say. So let's start by understanding that what is a robot. So if we see the definition, so these are the agents, physical agents that perform the task by manipulating the physical world. And to do so, they are equipped with the effectors. For example, with the legs, with wheels, with joints, and with grippers. So effectors, they have a single purpose: to exert physical force on the environment. There are many terms like environment, state, effectors, and we have already discussed all these terminologies. Fourth point is that robots, they're also equipped with the sensors. You already know what are the sensors, and which allow a robot to perceive the information, the knowledge from the environment. So they have effectors, they have sensors, and for some purpose, like to sense something from the environment and to assert the physical forces on the environment. Now, there are some more points about robot. So fifth point is that present day robotics employs a diverse set of sensors, and including the cameras and the lasers to measure the environment, and gyroscopes and accelerometers to measure the robots on motion. So there are many equipments to measure the robots on motion. And most of the today's robots, they fall into one of the primary category. First is the manipulator, or you can say the robot arms. They are physically anchored on their workplace. For example, in a factory assembly line or the International Space Station, or you can say ISS. Now, the second topic is robot hardware in robot. So we are studying this major terminology, that is robot, and the second subpart is the robot hardware. So in robot hardware, sensors, what are the sensors? Well, sensors, they are the interfaces between the robot and the environment. And there are some passive sensors, for example, cameras. They're the true observers of the environment, and they capture the signals that are generated by the sources in the environment. Active sensors are there. So the sensors, they can also be divided into the two categories. First is active sensor and second is passive sensor. So active sensors such as sonar send energy into environment, and they rely on the fact that this energy is reflected back to the sensor. So the active sensors, they tend to produce more information in the comparison to passive sensors. So just remember that this is about that what are the basic differences between the active and the passive sensors. Okay, so active sensors, they provide more information than passive, and at the expense of increased power consumption and with the danger of interference when making active sensors are used at the same time. Whether active or passive sensors, they can be divided into three types depending on whether they sense the environment, the robot location, and the robot internal configuration. Now, there are some terminologies like range finders are there, stereo visions are there. Okay, so range finders are also the sensors that measure the distance to nearby objects. And in the early days of robotics, robots were usually equipped with the sonar sensors. Sonar sensors, they emit the directional sound waves which are reflected by the objects with some of the sound making it. Next, we have stereo vision. So they rely on multiple cameras to image the environment from slightly different viewpoints and analyzing the resulting parallax in these images to compute the range of surrounding objects. So for mobile ground robot sonar and stereo visions, they're not rarely used because they're not reliably accurate. Okay, so the usage is limited. Other range sensors, they use the laser beams and special pixel cameras that can be directed using the complex arrangements of the mirrors or rotating elements. And these sensors, they are known as lidars. As you may have heard about these things, that what are the lidars? Lidars stands for light detection and ranging, and such type of the sensors, they are known as scanning lidars. Now, the other common range sensors, including radars, which is often the sensor of choice for UAVs, that is ultraviolet radiations, and the radar sensors, they can measure the distances of multiple kilometers. On the other extreme end of range sensing are tactile sensors. So in these points, I am discussing that what can be the different types of the sensors, what is the basic difference between the passive and active sensor, and there are many examples of the sensors. So if you are asked a question on sensor or write a short note on sensors, then you can just list these points. So here, radar sensors, they can measure the distance of multiple kilometers, and on the other extreme end of the range sensing are the tactile sensors. What are the tactile sensors? For example, whiskers, bump panels, and touch sensitive skin. So these sensors, they measure the range based on physical contact and can be deployed only for sensing the objects very close to robot. Now, the second important class of sensor is location sensors, and most location sensors, they use the range sensing as a primary component to determine the location. Outdoors, GPS stands for the Global Positioning System, is the most common solution to the localization problem. So this is also the important class of the sensors, and that is the location sensor. The third important class is the proprioceptive sensors, which inform the robots of its own motion. Okay, so these are the sensors of interest, and to measure the exact configuration of a robotic joint, motors are often equipped with the shaft recorders that count the revolution of motors in small increments. And lastly, we have inertial sensors such as gyroscopes that rely on the resistance of mass to the change of velocity, and they can help reduce uncertainty. So this is it for today. We have discussed many topics like MT, machine translation, statistical machine translation, what is a procedure for the translation of for the conversion of the languages, you can say. And then we have studied that what is the speech recognition systems, what is a procedure, what are applications, what are some of the difficulties in doing so, and then various models of it. And then lastly, we have discussed robots. What are the robots? What is the robot hardware? What are the sensors? And what are the different types of the sensors? So this is it for today, and in the next lecture, we'll be discussing robot perception. So thank you.